Okay, now in video 4, we want to accomplish a mass spring system that's being hung in the vertical. Let's do our same mass, 250 grams, and a spring of K equaling 25 Newton per meter. Now using the equation T equals 2 pi times the square root of m divided by k. We've already determined that the period for this wave is 0.63 seconds in a previous video. Okay, so we're going to pull this down from the equilibrium position 5 centimeters and let it oscillate back and forth. But we need to find the equilibrium position first. Okay, well, we know that gravity downwards and we have spring force upwards must equal each other. Okay, and I'll do little lines on like that. So we can find our equilibrium position here. So we're going to say force of gravity equals the force of the spring. Okay. So force of gravity is 0.250 times 9.8 equals 25 times x. Well, it turns out x is equal to 0.098 meters, but I'll just record that in centimeters, so 9.8 centimeters. Okay, so our zero position here is 9.8 centimeters of stretch. And we'll need to remember that when we calculate other energies involved with this. So this is our zero line here. But we're going to pull this up and back and forth 5 centimeters. Let's pull it down first. So we'll call that the negative 5 centimeters here. And it's going to oscillate back and forth between 5 centimeters. Okay, and negative 5 centimeters. Now again, assuming that there is no friction here, we're going to notice that the wave just keeps going back and forth like this. It would dissipate, of course, if there was friction. So we're going to end up with the same amplitude graph, okay, that we had in our previous video. So we're going to be 5 centimeters and negative 5 centimeters. Okay, so it's all going to be the same. We're going to start at negative 5, but let's do our little graph thing here. We know we have 0.63 seconds here and 0.31 seconds here at the half mark there. So in green here, let me superimpose. Oh, I'll choose blue. So let me superimpose our wave. So we're going to start at negative 5. So I'll put a dot there. Okay, we're then going to go up to the 0 mark. So I'll put a dot there. Okay, then we're going to go up to the 5 centimeters. So I'll put a dot there to correspond with that. And then we'll oscillate back down to 0. And finally, we'll end at the negative 5, which I'll put right here. And this is what our first wave is going to look like. And we see again that that's a cosine graph. Now our job, the next part of this is going to be looking at the velocity versus time graph for this. Okay, and the acceleration versus time graph for this, as this oscillates back and forth. And I'll save that for the next video.